Nowadays, the biggest problem in MOSFET manufacturing process is short channel effect, but it's inevitable while scaling down the devices, so we should overcome as possible as we can. Before we start talking about these issues, we should know that the good device should work as fast as it can and turned on and off easily. The first issue is called punch through. It occurs by the overlap between depletion region in body. And in this situation, leakage current generates in this region, so it has poor subthreshold swing, which means it's hard to turn on or off this device, and poor power efficiency. To overcome this problem, many ways have been researched to increasing the substrate doping rate to narrow the depletion region, and inserting insulator on silicon to block this depletion region, and inserting buffer over here. But because of the heat and price problem, these are not usual. And the second issue is VT roll-off. It occurs when the channel length is extremely short and the overlap between the channel and depletion region occurs. It's quite a serious problem because the threshold voltage directly influences on subthreshold swings. Actually, it follows this equation, so to overcome this problem, we should shorten the junction depth and enlarge the oxide capacitance. The third issue is drain-induced barrier lowering, which is called DIBO. It means how much the threshold voltage decrease by change of drain bias without the change of gate bias. Of course, device with bigger DIBO has bad subthreshold swing, and it gets serious when the channel length is shorter. The next issue is velocity saturation problem. When the lateral electric field between drain and source exceeds the critical electric field, the electron's velocity gets saturated. So by the Ohm's law, the current will be decreased because the velocity does not increase anymore, so it makes the device slower than we thought. The last one is gate-induced drain leakage, which is called GIDO. When the negative gate bias is given, a new channel between the gate and drain will generate. So in this region, leakage current will flow. So at the off state of the device, the current will generate. Most of these issues occurred by the strong lateral electric field between the source and drain. So, to overcome all these issues, we should fundamentally reduce the lateral electric field. To solve this problem, we insert LDD, low doped drain, at the junction of the source to channel and channel to drain. It makes junction potential decreased, so it will reduce the lateral electric field.